In this video, we're in lesson 3.2 on page 53 in our student journal, and we're going to work through exercises 1 through 8 in the extra practice section. One thing to remember before we start is that I, the imaginary part of our imaginary numbers, will be equal to the square root of -1. So when we're going to find square roots of numbers, notice that all of these are square roots of negative numbers, so we're going to be working with imaginary numbers. The first thing we're going to do is we're going to rewrite our square root. So the square root of -49, I'm going to rewrite that as the square root of +49 times the square root of -1. And so I'm going to break it up like that so I can get rid of that negative in the 49 underneath that square root. Well, the square root of -1 is I. So this is equal to the square root of 49 times I, or I times the square root of 49. We will always put the I in front of the square root. And so now I'm going to take the square root of 49. The square root of 49 is 7. So my final answer is 7I. All right, and number 2, the first thing I'm going to do is rewrite this as the square root of +4 times the square root of -1. And again, the square root of -1 is I, so I'm going to rewrite this as I times the square root of 4. Eventually, you can start to skip this step here and just go ahead to putting I in front right away. Okay, but this is an important step to understand what's going on. We're rewriting it like this and then putting I out in front. Okay, the square root of 4 is 2. So my final answer is 2I. All right, now remember the square root of -45, I can think about rewriting that as the square root of 45 times the square root of -1. We know this is equal to I, so this will be equal to I times the square root of 45. Now I want to check to see if I can simplify this, right? Because the square root of 45 is not a perfect square, but I do need to see if I can simplify. So I want to use my jailbreak method. Remember, you can take 45 and find the factors, the prime factors. So you have 5 times 9, and 9 breaks up into 3 times 3. So I'm going to rewrite this as I times the square root of 5 times 3 times 3. I'm looking for pairs, right? 3 times 3, that's a pair. So I can break out the 3's, only one survives. Okay. Now, when you break out a 3, you're left with 3I times the square root of 5. You might not have needed to use the jailbreak method. You might have realized, okay, 9, a perfect square, goes into 45. So you might have thought about it like this. This is equal to the square root of 9 times 5. And you know, because 9 is a perfect square, that the square root of 9 is 3. And so you might have went just right to pulling that 3 out. Okay. You don't have to use the jailbreak method if you're able to easily find perfect squares that divide evenly into the number underneath the square root symbol. All right. -2 times the square root of -100. I'm going to rewrite this as -2 times the square root of 100 times the square root of -1. Well, the square root of -1 is I, so I'm going to rewrite this as -2I times the square root of 100. 100 is a perfect square. I can take the square root of 100. The square root of 100 is 10. And -2 times 10 is -20. So my final answer is -20I. In number 5, I have 6 times the square root of negative 121. Instead of rewriting it as by multiplying by the square root of negative 1, I'm just going to go ahead and pull out that I just start. So I know this will be equal to 6I times the square root of positive 121. (121) is a perfect square. The square root of 121 is 11. And 6 times 11 is 66. So my final answer is 66I. Again, instead of rewriting it by multiplying by the square root of negative 1, I'm just going to go ahead and pull out I right away. So this 5 times the square root of negative 75, I can rewrite that as 5I times the square root of 75. And we want to see if I can't simplify the square root of 75. So 75 can be broken up into, I can automatically think that the perfect square 25 divides into 75. So that can break up into 25 times 3. Now you could break that up into 5 times 5 if you wanted to use the jailbreak method, but I'm going to go ahead and just write this as the square root of 25 times 3. And since 25 is a perfect square, I can take the square root of 25 to get 5. So the square root of 25 is 5. And I'm left with the square root of 3. Don't forget to simplify even further by multiplying these 5s together. So 5 times 5 is 25. All right, in exercises 7 and 8, find the values of x and y that satisfy the equation. So if I look at where x is in this equation, negative 10x plus I equals 30 minus yi, notice x is part of the real portion of this expression. And so what I want to do is I want to find the real part of this expression on the right, which is 30. I'm going to set those equal to each other. So negative 10x is equal to 30. Now my y is in the imaginary part of this expression. And so I'm going to set that equal to the imaginary part over here. So I is equal to negative yi. And I really don't need to write my i's. I'm just interested in the coefficients or what's in front of the i's. Okay. So this is plus 1i and this is minus yi. And so really what I can do is I can set up my equation up like this. 1 equals negative y. I don't really need the i's in my equation. I'm just going to set the coefficients equal to each other. So I'm going to solve these two equations for x and y. To get x by itself, I'm going to divide both sides by negative 10. And I get x is equal to negative 3. And to get y by itself, I have to get rid of this negative by dividing by negative 1. And I'm left with y is equal to negative 1. Okay, so in number 8, I'm going to do a similar thing as I did in number 7. My x is part of the real part of that expression. So I'm going to set that equal to the real part on the left. So 44 is equal to negative 1/4 x. For the y's, that's part of the imaginary part. So I'm going to set that equal to the imaginary part on the right. Remember, I don't need to include the i's. I'm just going to set the coefficients equal to each other. So negative 1/2 y is equal to negative 7. I'm going to solve these two equations. Okay. To get x by itself, I'm going to multiply by the reciprocal. I'm going to multiply by negative 4 on both sides. When I do that, I get x is equal to negative 176. In this equation, to solve for y, I'm going to multiply by the reciprocal, which is negative 2. And y is equal to positive 14.